Hello, welcome to the fifth session on the topic pipes and cistern. Let us start solving this question. Two pipes A and B can fill a tank in 15 minutes and 20 minutes respectively. Both the pipes are open together, but after 4 minutes, pipe A is turned off. What is the total time required to fill the tank? The numbers involved are 4, 15, 20. So you can take their LCM to be 60. Assume that 60 liters is the volume of the tank. A takes 15 minutes and B 20 minutes. So in 1 minute, A fills in how much? 16 upon 15 and B 16 upon 20. Or you can also write this is 4 and this is 3. 4 and 3 liters is being poured into by pipes A and B in 1 minute. How about 4 minutes? In 4 minutes this will be 4 times 4 plus 3. 4 into 7, which is 28 liters. 28 liters are already full out of 60 liters. What is remaining? Remaining is 32 liters. 32 liters is being left at this moment, and pipe A is now turned off. So only pipe B works, and pipe B can pour in 3 liters every 1 minute. That's why to fill in 32 liters, to pour 32 liters, the time taken will be 32 by 3. 32 by 3 minutes, it will give you 10 point something. Now 10 point something minutes to fill in this 32 liters, and for 28 liters it was 4 minutes, because both of them, A and B, have worked for 4 minutes at the start. So total 10 plus 4, 14 point something, 14 minutes plus few seconds. Okay, option D should be the answer. Let's take the next question. A large tanker can be filled by two pipes A and B in 60 minutes and 40 minutes respectively. How many minutes will it take to fill the tanker completely from empty state if B is used for half the time and A and B fill it together for the other half? Now again, let us use the LCM method. 60 and 40 are the numbers involved. We can take 120 to be the LCM, and 120 liters, let 120 liters be the volume of the tank. Okay. A and B take 60 minutes and 40 minutes respectively to fill in this 120 liters. Thus in 1 minute, A fills in 2 liters, 120 by 60, and B 120 by 40, that is 3 liters. And together in 1 minute, 2 plus 3, 5 liters they can pour in into the tank, both A and B together. Let us assume the total time taken is 2t. Okay, so you can divide 2t into 2 time periods, t and t, equal time periods. In this time period, first time period, B is used, and in the second time period, A plus B both are used. Since B pours in 3 liters in 1 minute, for time t, B will pour in how many liters? 3t liters. Agreed? Now, how about the second time period where both A and B are working? Together in 1 minute, A and B can pour in 5 liters. So, in t minute, they will pour in how much? 5t liters. Now, according to the question, this 3t plus this 5t is nothing but the total volume of the tanker, which we had assumed to be 120. 8T is 120. T is given as 15 liter. 15 time is, this is minutes, sorry, this should be 15 minutes. T is 15 minutes, but we have been asked the total time. We have been asked the total time. How many minutes will it take to fill the tanker from empty state? Total time we had assumed to be 2T, so the value should be 2 into 15 or 30 minutes. It exactly takes 30 minutes to fill the tanker completely in this fashion. Let us check out the next question. Two pipes A and B can fill a cistern in 12 minutes and 15 minutes respectively, while a third pipe C can empty the full tank in 6 minutes. A, B are kept open for 5 minutes in the beginning, and then C is also open. In what time is the cistern emptied? Okay. A, B and C are 3 pipes, A doing positive work, B also doing positive, and C emptying the tank. Now A takes 12 minutes, B 15 and C takes 6 minutes. Since the numbers involved are 12, 15 and 6, let us take the volume of the tank to be the LCM between LCM of 12, 15 and 6, which is 60 liters. 60 liters to be the volume. Now in 1 minute, A pours in how much? 60 upon 12. 5 liters in 1 minute. B pours in how much? 60 upon 15. 4 liters. So together A and B pour in 5 plus 4, 9 liters in 1 minute. Therefore in 5 minutes, A and B together will pour in how much? 5 into 9. 45 liters. 45 liters is filled in. Now after 5 minutes, who all are working? A, B and C, all three are working. We have already got that in 1 minute A pours in 5 liters, B pours in 4 liters. C also we can write 60 upon 6 or 10 liters, and this C is doing the negative work. Okay, so it is emptying out 10 liters every 1 minute. Now you see in 1 minute A pours in 5 liters, B pours in 4 liters, but in 1 minute C pours in 10 liters. Total, when A, B and C are working, in 1 minute, the tank is getting emptied by 1 liter. Every minute 1 liter is being reduced. So to reduce 45 liters, you would need how much? 45 minutes. 45 minutes to empty out the complete tank, and that is the time in which cistern will get emptied. Let's take the next question. Two pipes A and B can fill a tank in 6 hours and 4 hours respectively if they are opened on alternate hours, and if pipe A is opened first. In how many hours the tank shall be full? It is given that there are two pipes and they are opened alternately. So you can consider the first hour. In the first hour A is open, B is closed. In the second hour A is closed, B is open. Third hour A again is open, B is closed. Fourth hour B is open. Fifth hour and likewise. Okay, so they are working on the alternate hours. Numbers involved are 6 and 4. Let us take 12 to be the volume of the tank. 12 is nothing but the LCM of 6 and 4. 12 liters is the volume of the. Now in the first hour, A is working. So in 1 hour, what is the work done by pipe A? What is the work done by pipe A? 12 liters by 6. 2 liters. So 2 liters is poured in by A in 1 hour. How about B? In 1 hour, 12 upon 4, 3 liters. Whereas A can pour in 2 liters in 1 hour, B pours in 3 liters. So in the first hour, A works and A fills in 2 liters. How about B in the next hour? 3 liters, 2 liters and 3 liters. You see, we have reached 2 plus 3, 5 plus 5, 10. We have reached 10 liters here itself. And what is the remaining? Remaining is 12 minus 10, 2 liters. Now we know that A will be filling in 2 liters in the next hour. So in the 5th hour, at the end of the 5th hour itself, 2 more liters are filled in and the tank is full. 3 plus 2, 5 plus 2, 7 plus 3, 10 plus 2, 12 liters is done at the end of the 5th hour. So total time taken is 5 hours. Let's take the next question. 3 taps A, B and C can fill a tank in 12, 15 and 20 hours respectively. If A is open all the time and B and C are open for 1 hour each alternately, the tank will be full in. This question is similar in lines with the last question, except that there are 3 taps now. In the first hour, out of A, B and C, A and B are open while C is closed. Second hour, A is open all the time. So you can draw the diagram like this. And the second hour, B is closed, C is open. B is again open in third hour, C is closed. And likewise. The numbers involved are 12, 15 and 20. And their LCM will be 60. Consider 60 liters to be the volume of the tank. 60 liters to be the volume of the tank. In 1 hour, what is the work done by A? A will pour in how much water? 60 upon 12 or 5 liters. And B, 60 upon 15, 4 liters. And C will be 60 upon 20, 3 liters. Okay, 5 liters, 4 liters and 3 liters. In the first hour, A and B are working. A and B will put how much water? 9 liters. A and B will put 9 liters. How about A and C in the next hour? In the next hour, A and C will put in 5 plus 3, 8 liters. So you see that every 2 hours, total volume of water being pumped in is 17 liters. Okay, in the next 2 hours, again 17 liters would be put in. Again in the next 17 liters, 17 will be 51 liters. So we have got 51 liters in 6 hours. We have got 51 liters in 6 hours. Now what is the remaining? Remaining liters is 9. Remaining liters is 60 minus 51, which is 9. And this 9 liters will be put in by A and B in the 7th hour. Because in 1 hour they can pour in 9 liters. Okay, so total time taken will be 7 hours. This is not the correct option. 7 hours should be the answer. I hope you understood.